Do you hear me? It's okay, guys.
Yes, we can hear you.
Yes.
Thanks. Okay, so let's start. Today, we will discuss the demands on our goods. In the previous class, I explained to you how to solve the utility maximization program. And we will start from standard preferences. First of all, we will do number 2. So let us write down the utility maximization program. Number 2. So Ray spends her income on fuel for heating her house and a composite of all other goods. Her preferences are represented by the utility function. So let's write down the utility function that depends on heating and consumption of the composite good. The price of the composite good is normalized to 1. So let's write down price of composite good equals to 1, price of heating equals to P. And we have monetary income. Derive Ray's demand for heating and composite good. So first of all, we write down the task. We should find the Marshallian demand for heating. So let's say it's HD. It is a function out of prices of these two goods that depends on the price of heating, depends on the price of composite good, and depends on income. So this is our task, and also the same for the composite good. From the utility maximization program, we will find the demands, the Marshallian demands. So let's start. Your first step is to write down the utility maximization program. So we write down our utility function. We want to get the highest level of satisfaction that is affordable for us. So we maximize our utility by choosing the bundle, by choosing how much heating we will buy and how much of the composite good we will consume, subject to our budget constraint. So our budget constraint, the price of heating multiplied by the amount of heating that we will buy plus 1, the price of composite good multiplied by Y. And these expenses should be less or equal than our monetary income. So this is our program. First step of the solution is to prove that we will spend all our monetary income. There are different ways how to prove it. The easiest way is to assume that we spend less than our income and to prove that it is not optimal for us. This is in this case there is no there can be better solution of our utility maximization program. So we assume that we spend less than our monetary income and prove that it is not optimal. For example, we can increase the spendings on good Y, we can increase the consumption of good Y, and the utility will increase in this case, such that we can make our utility level higher. Yes, we can get the higher level of satisfaction. That's why we will buy more and more of composite goods, such that we will spend all our monetary income. So this is the first option, how to prove that we will consume on our budget line. We will choose the bundle on our budget line. The second option, how to solve it, we can prove that our preferences are monotonic. Yes, how to prove it? We can count the marginal utility from consumption of heating. This is the partial derivative out of by heating out of our utility. And this is 1/2 square root out of h. And we see that marginal utility is positive. What that means? That means that the higher the consumption of heating, the higher level of utility we will get. Our utility increases. So our preferences are monotonic according to subject to the heating. And the same, we can count marginal utility from our composite good. And it's similar, 1/2 square root out of y. And it's also bigger than 0. That means that the higher the consumption of the composite good, the higher level of utility we will get. And from here, we say that our preferences are monotonic. That's why we will spend all our monetary income. It is optimal to spend all monetary income. Okay, so now we proved that we will our bundle, our optimal bundle will lie on our budget line. Okay, and then we're ready to solve the utility maximization program. We have two different ways, maybe more. I will show you two ways how to solve it. So the first way is through math, and the second way through our economic theory. So let's start from the first way. So let us write down one more time our utility maximization program. Should maximize it by choosing y greater or equal than 0. So now we have a utility function depends on two variables. From our budget constraint, we can find y. It will be equal to monetary income minus pH, and put this into the utility, and we will get the function that depends on only one variable, and it will be easier to solve it. So let's put it square root out of h plus square root out of m minus pH. And now we will maximize such function that depends only on the heating. Heating should be non-negative, but also now we will have the upper border. So because our consumption of the composite good should also be greater or equal than 0. From here, we find that heating should be less or equal than our monetary income divided by the price of heating. And here we put this upper border. So now we're ready to solve. We have, we will speak about interior solution when we consume the positive amount of heating, but less than our monetary income over price. And also we have two corner solutions. I will show all these solutions. So first solution is interior. So here heating, here our utility, here 0, and here upper border, m over price. And let's assume that this is like our utility function, and this will be maximal utility level. This is optimal amount of heating that we will consume. So first order condition is that tangent line in this point should be horizontal. That means that the first derivative should be equal to 0. So let's do it. First derivative is 1/2 square root out of h minus price over square root out of m minus pH. and it should be equal to 0 for our heating that belongs to from 0 to m over price. So from here, what we should find? We should find the amount of heating, the demand for heating. So let's solve it. Here, 2. So we delete 2 and do the cross. So here will be square root out of m minus ph equals to p square root out of h. So put everything in the power of 2. There will be m minus ph equals to p square h. And then, so heating will be equal to monetary income over price multiplied by 1 plus price. And we should prove that our solution lies in the interval that we consider. So first of all, it should be greater than 0, but that's true for each monetary income and each price, because monetary income and prices are positive, everything is okay. And also we should prove that that the heating will be less than monetary income over price. And we see also that it is true, because when we solve this inequality, 1 plus price less than monetary income over price, we can delete everything and do the cross. Here will be 1 less than 1 plus price, and that's true that price should be greater than 0. It's okay. So we checked that we consider interior solution, and now we're ready to consider 2 corner solutions. The second is the second option is corner solution. So let me show you how it can look like. Here 0, here m over price, and it can be, we will check, can it be that the utility reaches the maximum when the heating is negative, and we do not consider negative amount of the good, so our solution will be here, the maximal utility we will get when heating is equal to 0. But this will be the solution only if in this actual point the tangent line will have negative slope. And we write down this. So our derivative in this actual point should be less or equal than 0, and in this case our solution will be not to consume any heating. So let's check it. Let's check it. We know the partial derivative, so this will be 1 over square root out of 2 square root out of 0 minus price over 2 square root out of m. And you see that the first part is close to plus infinity. So plus infinity minus some constant is actually positive. So we will have no solution, no such corner solution. Yes. So here is contradiction. That's why we will not have such corner solution. And let us consider the second corner solution. The second corner solution can be when we will spend all our monetary income on the heating. So our utility function can reach the maximum somewhere here, and we cannot consume such amount because according to our budget constraint. That's why we will choose to spend all our monetary income on heating. And in this case, in this point, tangent line to our utility function should have positive slope. Yes, and we write down this. So the first derivative in the point when heating is equal to m over p should be greater or equal than 0. In such case, only our optimal consumption of heating will be equal to m over price. And let's check it. Let's put this point into our first derivative. Let's check it. So 1 over 2 square root out of m over price minus price over m to square root out of m minus price multiplied by m over price. You see that in the second part, in denominator, there will be 0. So let me write down this here. 1 over 2 square root out of m over price minus price over 2. And you see here is 0. And the second part, you see it is close to, let's consider this with minus. This part is close to minus infinity. So this first derivative in this point will be negative. But to have such corner solution, it should be positive. So we do not have also such corner solution. So our demand will have only one part, the equation for demand. So you see here is contradiction. That's why we do not have such corner solution. Now we're ready to write down. This was only first order condition, but we should also check second order condition. Why? We should prove that this point in which we will consume is actually for maximum of utility level, because here can be other situation that our utility looks like this, and in this point it's also tangent line is also horizontal, but we should check that we are speaking about maximal level of utility. So here we will have minimum, but we should check that we will reach maximum. For maximum, as you remember, the second derivative should be in this actual point should be less or equal than 0. We will not check this right now, but you should do it in your homeworks or in classes or in when you will write midterm or exam. So the second derivative in this actual point that we found from first order condition should be less or equal than 0. Then it will be maximum, and we should check it. Let me write down, check it by calculating. My calculations. Okay, now we're ready to write down the demand function for the heating. This will be the function from the price of heating, from the price of the composite good, and from the monetary income. And we found it from first order condition. Let me see. It's here. This one. So it will be a monetary income over price multiplied by 1 plus price. So this is the demand for the heating. What we can check? We can check our logic. Maybe we made some mistakes in calculations. Here we can check the law of demand, and definitely the higher the price, of the heating, the lower the quantity demanded. Okay, law of demand we checked. Law of demand checked. And what we can say about the connection with monetary income. You see that the higher the monetary income, the higher the demand for the heating. That's why we can call such good normal good. Yes, normal good. Okay, but also we had tasked to find the demand for the composite good. So we can find it through budget constraint. So we know that composite good, it is, let me see, from budget constraint, M minus PH. M minus P multiplied by the demand for heating. And put this. So this will be M minus price multiplied by M over price, 1 plus price. Delete this. So put into the numerator, there will be M1 plus price and minus 1 over 1 plus price. So the demand for the composite good will be M multiplied by price over 1 plus price. And P is the price of heating. Yes. So here, let us check that that our composite good is actually normal good. So it will be strange in the situation when composite good will be inferior, because composite good is all goods that we consume except the heating. So this is logical check. Normal good. Okay, so this was the first way how to solve the utility maximization program. But in the previous class, we considered the second way by using economic theory. So let us consider the second way how to solve this utility maximization program. Let's write down one more time. Plus square root out of y, we should maximize by choosing two variables, h and y greater or equal than 0, subject to budget constraint. So, as you remember, let's draw the graph. Let's draw the graph. Here will be heating, here composite good. Let's draw the budget line by using, this is the linear function, we can use 2 points. So if y is equal than 0, then h will be equal m over price of heating, and vice versa. If h is equal to 0, y will be equal to our monetary income. So connect these 2 points. This is our budget line. Always name all curves that you present on the graph. Then we should draw indifference curves. Yes, and we should understand how to draw it. Yes, how to draw the indifference curve. You know that indifference curve consists of all bundles that brings us the same level of satisfaction, the same level of utility. So we fix our utility level. This is constant utility level, and all such bundles that belongs to such indifference curves will bring us to the same level of utility. And as we have composite good on the vertical axis, let's find it. So square root out of y equals to u minus square root out of h, and y equals to u minus square root out of h in the power of 2. You know You know that square root is the branch of parabola, and when we have it with minus, so it will look like this. So this is with plus and with minus like this. Yes, and that's why we will consider standard preferences. So our indifference curves will look like this, the reverted branch of parabola. So now we understand that we are speaking about standard preferences. So let's show the highest indifference curves. The highest indifference curve, which we proved that we have strictly monotonic preferences. That's why the higher, the bigger the consumption of both goods, the better we are. So let's put the direction of the utility increase as always, and draw the highest indifference curve. This will be the last touch with our budget line. This is indifference curve. Always name all curves. And this will be the solution of our utility maximization program. This is the demand for heating. This is the demand for composite good. Okay, as you remember, in this actual point, in this optimal point, you see that budget line becomes a tangent line to indifference curve. We know the slope of the budget line, it is the price ratio, and the slope of indifference curve we considered in the previous class, it is marginal rate of substitution. Yes, so in interior solution, what means interior solution? When we consume the positive amounts of both goods. Marginal rate of substitution of heating by the composite good in this actual point, optimal point, should be equal to the price ratio, PH over PY. This is the slope of our budget line. This is the slope of budget line. And this is the slope of indifference curve. And also, we should spend all our monetary income. So such point should lie on the budget line. So we write down this price of heating multiplied by the amount of heating plus the price of composite good multiplied by the amount of composite good. These are spendings on both goods, should be equal to the monetary income. So this is, you see, two equations with two unknowns, and we can find it. Let us find the marginal rate of substitution. There's a formula. You remember that this is the ratio of marginal utilities, marginal utility from heating over marginal utility from composite good. We just calculated it. It is 1 over 2 square root out of h, and here 1 over 2 square root out of y. So we revert everything, and we will get square root out of y over square root out of h. And let's put this into our first equation. So the solution will be square root out of y over h equals to price of heating is equal to P, price of composite good equals to 1. So here price over 1. And price by heating plus 1 by composite good equals to monetary income. So from here, we will find the demands for both goods. So let's calculate. From the first row, y equals to price square multiplied by heating, and put this into budget constraint. And we find the same solution. Yes, the demand for heating equals to monetary income over price multiplied by 1 plus price. The same. Yes, but this is only interior solution. Also, we should check corner solutions. So the first corner solution, the demand for the composite good is price square multiplied by the demand for heating, and it is price multiplied by monetary income over 1 plus price. Good. Then also, because we considered interior solution, this should be positive, and this also should be positive. But that's true for all M and all P. So this is true for all monetary incomes and prices. But nevertheless, let us check corner solutions, because now I explained to you how to solve the utility maximization problem in general. So first, corner solution. Corner solution 1. Let's consider the situation when we spend all our monetary income on heating and do not buy other goods. And let me remind you how it can look like. Here heating, here composite good. This is our budget line, and we want to prove that actually this point will be the solution. Here M over price, when it will be the solution, when the last intersection of indifference curve with budget line will be in this actual point. It will look like this. So the direction of the utility increase, this is indifference curve, and you see that for such solution to exist, in this point, the slope of the budget line should be less than the slope of the indifference curve, you see? So let's write down it analytically. So for such point to be the solution, then the slope of our budget line, it is the price ratio, and it should be less than the slope of indifference curve in this actual point, and the margin rate of substitution of heating by the composite good in this actual point when the heating equals to M over price and Y is equal to 0. So, and also, that's true that we will spend all our monetary income. So let's check if we have such corner solution. We know the price ratio, it is price, and this should be less than, let's put our point into margin rate of substitution. This is square root out of y is equal to 0 over M divided by price. And you see that this is equal to 0. And for such point to be the solution of our utility maximization program, price should be less than 0. But that's not true, because price is positive. So such solution does not exist, because our price is greater or equal than 0. And here we have contradiction. And also let's check another corner solution when we spend all our money only on composite good. Corner solution 2. This is the polar situation when heating is equal to 0 in optimum, and we spend all our money on Y. So I will remind you how it can look like. First of all, you always draw budget line, and we want such point to be the solution. Here, M. Sorry, here no price, because this is the price of H. Okay, so for this point to be the solution, the indifference curve should intersect with budget line in this point. The direction of the utility increase, this is indifference curve. So pay attention that I always name all lines and I always draw the direction of the utility increase. So you see that in this point, to be the solution, the slope of indifference curve should be lower than the slope of the budget line. Yes? So let's write down it. This will be the solution only if the slope of the budget line, this is the price ratio, should be bigger than the margin rate of substitution of H by Y in this actual point when the heating is equal to 0 and Y is equal to M. And let's check it. Let's check it. So from here, price ratio equals to P, and this should be bigger than square root out of Y is equal to M divided by 0. And you see that margin rate of substitution is close to plus infinity. But the price cannot be bigger than plus infinity. That's not our case. And also, we make the conclusion that such corner solution does not exist. After checking all situations, all solutions, we come to conclusion that these are demands. This is the answer for our task. This is the answer. So that's all for number 2. So please, guys, ask what to repeat. Is it clear?
Yes.
So I hope, because I explained to you in the previous class in general, yes, and now we consider the example. So now let's proceed to number 1. In number 1, we will not have standard situation. We cannot use this equality of price ratio and marginal rate of substitution. So let's check how to solve points in number 1. These are our situations with perfect substitutes and perfect complements. Now we consider number 1. So demand for good 1 for consumers whose preferences can be described by the following utility function. So here will be x1 plus 2x2. Let me write down this. x1 plus 2x2. x1 plus 2x2, number 1a. x1 plus 2x2. This is the utility function. And as always, to find the Marshallian demand, we should solve the utility maximization problem. You always write down the problem and then the solution. So we want to maximize it by choosing how much x1 to consume, how much x2 to consume, greater or equal than 0, subject to our budget constraint. But let's check. Okay. Let's say that the price of good 1 is P1. These are spendings on good 1 plus the price of the good 2, x2. And this should be less or equal than the monetary income, but okay, I will show one more time, less or equal than M. So this is our utility maximization program. First, you prove that you spend all the monetary income. So we assume that in optimum we spend less, and we prove that this is not true, because if we increase, for example, the consumption of x2, our utility will increase, and we will increase our spendings on x2 such that we will spend all our monetary income. Now, let's draw such situation. before drawing, okay, let's draw. Actually, we will have 3 situations, but let's consider the first one. Here is x1, here is x2. First, you draw the budget line, as always. Budget line. Here, the maximal amount of x1 and x2. Let's find marginal rate of substitution, because we are speaking about perfect substitutes. Perfect substitutes. Let me remind you how indifference curves will look like for such perfect substitutes. So let's find indifference curve. We fix the level of utility here, x1 plus 2x2, and x2 is on the vertical axis. So let's find x2. x2 equals to u over 2 minus 1 over 2 x1. You see that this is linear function with negative slope, and the slope is 1/2. Yes, minus 1/2. So the last intersection with our budget line can be we can have 3 different situations. So let's consider the first situation. The first situation when the price ratio is bigger than the slope of the indifference curve, the slope 1/2. So how our indifference curves will look like? Indifference curve is flatter, yes, something like this. Here, 1/2. This is the indifference curve. But as I draw, this point will not be the solution, because we can increase our level of satisfaction. Yes, the last intersection with the budget line will be here. Yes, so this is one more indifference curve, and this will be the solution. So for perfect substitutes, we will have corner solutions. Yes, so this is actual demand for x2, and x1 is equal to 0. And we are ready to write down this answer. So if the price ratio P1 over P2 is bigger than 1/2, then the demand for x1 is equal to 0, and the demand for x2 is equal to m over price of good 2. What is 1/2? 1/2 is actually the marginal rate of substitution. You can check it one more time. Marginal rate of substitution of the first good to the second good equals to marginal utility from the first good or marginal utility of the second good. These are partial derivatives by x1 by x2. And you see that this is 1 over 2, 1/2, the slope of the indifference curve. Okay, then let's check another situation. The second situation is vice versa, when the price ratio is less than 1/2. So indifference curve will be steeper than the budget line, and the last intersection will be in another corner solution. Here, indifference curve 3. No, indifference curve. This is the other situation. The direction of the utility increase is always, and let's write down it. If the price ratio is less than 1/2, then we will spend all our monetary income on the first good, and we will not consume the second good. And the last situation, I will not draw it. Okay, I can draw it. If price ratio actually equals to 1/2. In such situation, the slope of indifference curve is equal to the slope of the budget line. And this is the last indifference curve. They coincide with each other, yes? In such situation, we're indifferent which point to choose on our budget line, and we can write down it. So in such situation, x1 will belong to from 0 to m over price 1, and x2 from our equation of budget line is equal to m over p2 minus p1 over p2 x1. So this is the solution of our utility maximization program. Now, we're ready to write down the demand on x1. I think this is the task. Let me check. Yes, we should find the demand for good one, but actually we can write down the demand for the good two also. So answer. The demand for x1 as a function of price of good 1, price of good 2, and monetary income equals to, and we write down these three situations. Equals to 0 if p1 over p2 bigger than 1/2, equals to any point from 0 to m over p1 when x2 equals to m over p2 minus p1 over p2 x1. This is if p1 over p2 equals to 1/2, and here is and vice versa, m over p1 if p1 over p2 less than 1/2. So this is the demand for the first good. Now, let us check that law of demand is true here. For example, the higher the price of the first good, the lower the demand for this good. True. Yes, law of demand. What also we can say? Actually, let's check is okay. And let's write down the demand for the second good. It depends on price vector and m. It will be 0, vice versa. The price ratio less than marginal rate of substitution at this point. M over p2 if x1 equals to m over p1 minus p2 over p1 x2. This is when the price ratio equals to 1/2. And m over p1 or p2 if vice versa. So this is the solution of the utility maximization program for perfect substitutes. As you see, we do not have such standard preferences here, and we cannot use this last touch of budget line with indifference curve. We have here only corner solutions, only corner solutions, and that's true. You see, these are the same corner solutions, and you should do this check. And we do not have the last touch in interior solution, but difference curve coincides with the budget line in this case. So guys, please ask about the solution for perfect substitutes. Here we solve this problem by using our economic theory. We compare marginal rate of substitution with the price ratio, but also you can use the first method through math. I will write down it, but we will not solve it. The second method is to write down the utility maximization programs with one variable. So one more time, x1 plus 2x2, we should maximize by choosing x1, x2 greater or equal than 0, subject to budget constraint. Let me find it. So for example, x1 equals to m over p1 minus p2 over p1 x2. This should be greater or equal than 0. That means that x2 should be less or equal than m over p2. And you write down that m over p1 minus p2 over p1 x2 plus 2x2. Okay, let's find it. So here, 2 minus p2 over p1 x2 plus m over p1, and we will maximize it by choosing only x2, but it belongs to the interval between m over p2 and 0. You see that this is actually a linear function. This is constant, and this is coefficient k. Yes, this is the slope of linear function, and we can have these three situations about the utility. Utility here x2. These are borders m over p2 and 0. I will show all these cases. So if the slope is positive, you can have like this, our linear function, and this will be the solution. If the slope is negative, this here will be the maximal level of utility. And if the slope is equal to 0, we will choose any point from 0 to m over 2. So when we have the positive slope when 2 bigger than p2 over p1. When we have negative slope, vice versa, 2 less than p2 over p1. And horizontal slope when our utility is constant. Yes, this is 2 equals to p2 over 1 or over p1. So you can, this is the same. Yes, so you can choose the second method to solve this program. So, but I recommend to use marginal rate of substitution, the first method here. Now let us consider the polar situation. We will speak about perfect complements. Yes, the function of minimum. Let me see what is here. Minimum from x1 to x2. From x1 to x2. So point B, utility equals to minimum from x1 to x2. And budget constraint, as always. So we write down the program that we should solve. We should maximize it And how the indifference curves for perfect complements looks like. If you don't know, so let's find it. Indifference curve. We fix the level of utility. This is the minimum from x1 to x2. And let's write down the system. So the utility will be equal to x1 if it is minimum, yes? If x1 less or equal than 2x2. And utility will be equal to x2 if x1 greater or equal than 2x2. So our indifference curve consists of two parts. Let's draw it. X1, x2. And let's put this point when x1 equals to 2x2. So we have two areas, yes, two parts. So, x1 equals to, so x2 equals to x1 over 2. The slope is 1/2, so it will look like this. This is this line here, 1/2. And if we consider the area above this line, this is our first case or second case. Next to this first case, when x2 bigger than x1 over 2. To understand this, you can use any point that belongs to the to this area. For example, I don't know, x1 equals to 100, x2 equals to 100, x1 equals to I don't know, 5. Yes, and actually 100 will be bigger than 5 over 2. That's true. So we consider this point, this area. Okay, in this area, you see the utility level equals to x1. So x1 equals to constant. So this is vertical part. Some constant, and this is vertical part. And vice versa. In the area under our line, you see x2 equals to u over 2. So it will be here, u over 2. So x2 equals to constant. This is the horizontal line, this part. So this is the indifference curve for the case of perfect complements. And we also see that our preferences are monotonic, because the higher the consumption of both goods, the higher the level of utility. So preferences are monotonic. Not strictly monotonic, but monotonic. Okay, so we draw the direction of the utility increase, as always. Now, we understand what will be the solution of the utility maximization program, because the last intersection of the budget line with the indifference curve will be in this actual point when x2 equals to x1 over 2. So let's draw budget line. This is the solution. This is x1 star, and this is x2 star. This is the last intersection with budget line. But analytically, we should prove it. So let's prove it analytically. Suppose our solution lies above this this line, x2 equals to x1 over 2. So the solution lies above. That means that x1 is less than 2x2. But in this situation, the utility level equals to minimum x1. Yes? And we can improve such situation because we can increase the consumption of x1. We can increase the consumption of x1 such that utility level will increase. And you see that when we increase the consumption of x1, how we can do it? We should substitute, yes? We should take some spendings on x2, decrease the consumption of x2, and buy for this money some more x1. Such that the utility will increase. And we will do it up to equality. And vice versa. Suppose, let's say, so such situation is not optimal. So x1 less than 2x2 is not optimal. Now, suppose vice versa, x1 bigger than 2x2. In this case, the utility equals to minimum 2x2. So we can improve such situation. We can decrease spendings on what? On x1. Spendings on x1 and increase spendings on x2 such that the utility will increase. And we will do it until here will be the equality. Now we proved that it is optimal for us to consume such goods in the proportion 1 to 2. That's why it is optimal that x1 equals to 2x2. And this is the solution. Yes? And also this point should lie on the budget line. P1 x1. Wait. And from here we will find the demands. Michelin demands. So put the first row into the second row. And from here, we will find the demand for x2 as a function of prices and monetary income. This will be equal to M over 2P1 plus P2. And x1 equals to 2x2. This is 2m over 2p1 plus p2. Let's check the law of demand and what about these goods? Are they inferior or normal? As we see, the higher the price of good 2, the lower the quantity demanded. So law of demand, okay. Then law of demand, we checked. Then the same for x1, the higher the price of this good, the lower the quantity demanded. So that's true for both demands. Then what about the connection with another good? You see that the higher the price of the first good, the lower the demand for the second good. And we proved now that these two goods are complements. So you see, the higher the price of cars, the lower the demand for petrol, for example. Yes. So, and here the same, the higher the price of petrol, the lower the demand for cars. So these two goods are complements. And the last check, the higher the monetary income, the higher the demand for these both goods. So these goods are normal. And that's so this is the answer for our utility maximization program when we consider perfect complements. So today, what we did, we consider all almost all situations. So we did not consider quasi-linear preferences, but you can read about them in the textbook. Yes, in our textbook that is presented on the last slide of each lecture. So we consider today how to find the demand for standard preferences, this one. Then we consider the utility maximization program for perfect substitutes, and here will be corner solutions and all points on the budget line. And the last is about perfect complements. Pay attention that you should that the graph is not the proof that we should work on this line. Yes, you should prove it how I showed you. So I think that's all for today. So guys, is it clear for you how to work with such programs?
Yes, thank you. It's clear.
Можно вопросик насчет квиза? Вот это квиз, который был на завтра, то есть, или это квиз отдельный сегодня, который будет, ну, который был?
Ну, это пятый семинар. Завтра будет уже по 6-му.
Ага, то есть завтра уже будет следующий квиз. Все понятно. Спасибо большое.
Смотрите, да, поскольку вы просили, чтобы вам поставили экстра-класс, вот у нас сейчас с вами экстра-класс, да, чтобы мы нагнали лекции. Соответственно, завтра вы прослушаете лекцию по шестому семинару, и после этого у нас будут 6-е семинары. Поэтому, поскольку у нас квизы по материалам лекций, да, вам будут представлены вопросы, да, вот четко по этой лекции, очень простенькие, да, потому что, ну, то есть я не буду... раньше, да, я вам задавала вопросы по литературе, да, которая в конце слайдов, да, всегда написана. Теперь вот у вас будет какой-нибудь простенький вопрос, ровно потому, что рассказывает Юрий Владимирович. Вот, то есть
Понятно.
это
Спасибо большое.
Да, будет проверяться, как вы послушали лекцию. Вот, такие дела. Все, я с вами прощаюсь. Давайте, мы прям четко закончили с вами. Все, пока-пока.
Спасибо, до свидания.
Видео выложу.
Спасибо,
Пока.
до свидания.
До свидания.